More rolling in. All right, well, let's just get started. Thanks everyone for joining our TrafficLink user training. This session is going to be about our ATSPMs, workspace, and intersection health tools that you may or may not have heard a lot about over the last little bit. So we're going to focus on that first. But to get going, for those that don't know me, my name is Brent Rogerson. I'm an ITS sales engineer. I spend a lot of time helping our customers take advantage of the tools and the products that Miovision provides. And today I'm joined by Olivia. And maybe Olivia, you can introduce yourself.
Sure, thanks, Brent. Yeah, hi everyone. My name is Olivia Babcock. I'm a traffic engineering specialist here at Miovision. So really helping our customers to understand their data and help them to make any changes that might kind of improve things within their network, within their intersections, along a corridor, things like that. And happy to be here.
Awesome, thanks, Olivia. So we're going to get into quite a bit of content today, like we always do. The purpose of these sessions is to really, we're not going to do like marketing high level type of presentation. We're going to go deep into data. We want to make sure that we give some good examples. So we're going to do a quick overview of the software applications and which one we're focusing on today. We're going to go right into the ATSPM charts that are available and kind of break down where does the data actually come from. That's going to really get us kind of the foundational components of how ultimately what our intersection health tool does and where the data actually generates from. So we're going to kind of work our way through that and build up to the examples of intersection health at the end. And then we'll open it up for some questions and kind of see if anybody has anything that they want to talk about at the very end. So it'll be about 50 minutes of information and then about 10 minutes for questions. But as we go, feel free to put questions in the question box or just hold on to them to the end, and we'll try to address as much as we can. If not, we'll follow up after that. So let's get into it. So just quickly, a TrafficLink overview and what parts we're talking about. So as everybody probably knows, we have our components of devices here. We're going to really talk about the data and the sources of data that are coming off of these today, and you don't necessarily need all of them. So as many of you know, we have our SmartLink. The SmartLink is a communication device. This is what allows us to connect into the traffic cabinet. When we're in scenarios where there's existing detection, that's a data source. If we're bringing our own detection, which is the SmartSense device in the middle there, and that's providing the actuation, that all comes from our 360 camera, all populated up to the TrafficLink web portal. But generally speaking, these are our tools that allow us to generate all of the data. But in many cases, our customers have existing loops or existing detection that they can take advantage of with just the SmartLink. So as we talk about the data and some of the data sources along the way, keep that in mind. You could use just a SmartLink to connect some data that you do have already, and then we can start maximizing the use of corridors and connecting and completing the data story along the way. So we have these components. You can certainly think about that, and then we can build from there as well. The software applications that Miovision provides on top of that. So often we think about our tools in terms of software applications that get layered on as modules. We have 5 major modules: signal maintenance, video detection, performance measures, safety analytics, and continuous counts. Today, we're going to really focus on that performance measure application in the center here. So we're going to leave the other ones to the next session, which I'll talk about at the end, but today we'll go deep into the performance measures. So an ATSPM overview. So let's talk about what exists there today and where some of the data comes from. So many of you probably heard about automated traffic signal performance measures in the past. Many of you are probably using them, or maybe just asking, how do I use them? And that's why we're here today. But some foundational components to that is understanding where the data is coming from. So there's 3 major elements to this. The first one being the traffic signal controller itself. Typically, what we're pulling from this is really that signal status, so phase information. Is it green? Is it yellow? Is it red? And then what is the timing plan? Is it time of day? Is it free mode, those types of questions are what we're asking of the controller in terms of what is your current state. That phase information is what we compare to in terms of the operation. It allows us to understand the existing plans, coordination, and so on. The second set of data that we incorporate is detector activations or actuations, depending on if we're managing the intersection or not. This is coming from that stop bar detection or maybe upstream detection if, say, you have some setback loops, whatever it may be. This is where volume, pedestrian information, stop bar occupancy, this is where a lot of the major graphs are generated from in combination of the signal status. So if you think about, is the light green? Are there cars in the zone? Is the light red? Are there cars in the zone? That's somewhat the basis of most of these charts. The last component that we take advantage of is the Wi-Fi MAC address collection that is in the SmartLink antenna. This is a travel time tool. It allows us to pull in information for point like A to B type calculations or congestion scan to understand the overall progression through a corridor and really understand those indexes and reliability. So all of the data sources that we're using to generate the charts come from these three aspects. Really, the purpose of that is to gain that visibility of intersection operation. You may have some or all of the data coming in, depending on what you have at the network. The purpose of this is to give you the tools to create that visibility into the network. And if we break that down a little bit further, when I mentioned some of those tools, you may have seen some of these in the TrafficLink platform already, but I'll just kind of give a baseline of what they are, where they come from, and how we're going to use them in the intersection help tool at the end. But the first one is a little bit more basic in the understanding of travel time. We have two charts that are in here. Some of this is a complementary tool to looking at corridor progression, how well our car is actually traveling down a corridor. That comes from a corridor congestion scan. It allows us to review the, say, eastbound and westbound at all times of day to really understand how well are cars flowing through, where are they slowing down, and how reliable is that, to really give you a starting point. It shows you where to look in your network for where slowdowns are occurring throughout the day. A travel time chart is more basic, just point A to B. Do we have that? Does that provide you with more intersection to intersection and really getting to the level of what may have happened to cause slowdowns at different times of day? So it allows you to go a little bit deeper into the travel time. Next one down is around the upstream detection. So this is about setback detectors. This allows us to calculate approach volumes. So in the scenario where you don't have a Miovision SmartSense, approach volumes allow you to get a count off of the detector zone. We use the setback detector to collect that because we want the point at which they're still free flow or they haven't queued up yet, because we want to know what the count is as they approach. And this is the same concept for arrival on red or arrival on green. We want to know, are they going to arrive on red or are they going to arrive on green, not have they or are they at there when it's red. That's actually the next set of charts, but that comes from the upstream detection. Between those charts, it allows us to build the Purdue coordination diagram. Purdue coordination allows us to look at those detector hits in relation to the arrival on red and really see if we can determine platooning, how well are cars being served or how well is the demand being served in sense of the platoon and at what intervals are they arriving at the intersection. So that's from the upstream detection. The next one is around the stop bar detector. So these are the four charts that you'll most often see populated in our platform. They come from those stop bar detectors. This allows us to calculate an occupancy ratio on green, on red, and then in the first 5 seconds of red. Really what we're looking for there is to determine how well was the demand served. So how many cars actually got through, how many had to stop in that first 5 seconds of red. And by definition, that is called a split failure for the ones that didn't get serviced in that first 5 seconds, or they were the remainder cars that didn't get served when the light turned red. That's called a split failure. So what we have at the bottom there is a split failure chart to actually map out how well are they being served. And at the bottom is a trend tool to actually give you the frequency to really highlight the time of day it's being managed or not. And so it really gives you another way to look at which movement, which approach is struggling or is doing well or has spare capacity. And these charts are a large part of what our intersection help tool is that Olivia is going to get into near the end here. A couple other charts that we have there that you may come across. The top ones are more directly just the phasing information. So the one there you see phase interval, that's really just looking at how long was green, how long was red, what are all the durations over a 24-hour period. This is a raw form of signal phasing just to look at, is it running my time of day plan? Is it doing what I expect it to do? Is it in free mode? Is it in scheduled plans? Things like that. You can easily see that in phase intervals. Green allocation really just illustrates that distribution of green time over a 24-hour period as well. So it's really just looking at the timing aspect. The bottom one, pedestrian delay, this actually comes from intersections that have PED push buttons. So if you have a PED push button activated, you can see the time between when that button is pushed and the time that they get to cross the road. And it gives you an understanding of how often is that signal or that PED signal called, to really give you a full picture of the intersection operation. Because it is true that when we do analysis, it's easy in a vacuum to look at data and make suggestions or make assumptions from the data without really looking at all of the factors. So we need to make sure we're considering all the factors, considering all of the plans, considering all the priorities of an intersection. And these are all different types of charts that give you the tools to really assess that. Lastly, so one thing that you probably have heard from us recently is this concept of a workspace. What Workspaces allows you to do, you'll find it when you log in and you'll see in the Insights tab, you'll see intersection health comes up first, and then the second thing is ATSPM Workspaces. ATSPM Workspaces is where all of our charts are, but now it's in the context of actually building a workspace. This is where you put your charts together and then you can save that as a dashboard. The purpose of that is to really help save you time. And so you can get a problem identified, you can go create a chart, you can save that chart and come back to it later and then simply change the dates on it. Take that if you're trying to do an iterative approach to making improvements to the intersection. Workspaces actually allows you to save what you're working on and then come back to it later, or present it on an interval in a way that can save you a whole bunch of time. So this is a recent tool that just came out, and we did a really fun launch around it that we presented. A little bit of a challenge to the users to see how many people could go in and actually create a workspace around a problem. And we had an amazing engagement on that. It was a very helpful tool out of the starting gate. And I asked in the launch for anyone to submit an example of this. So if they could take a problem that they currently have and create a dashboard around it and really present the problem in the dashboard, and then we would choose the first 5 people to make a submission and send out some gift cards. And that was amazing. I saw some really good submissions. I did want to highlight one example just to show how it could be used. So there's a little bit of a problem statement here. So a customer of ours, the person that actually submitted the first one, I'm not actually sure if they're on this today. If they are, they'll recognize this. I won't use names, but I'll try to highlight the problem that was created with the workspace because I thought it was really interesting. So there's an intersection that one of our customers had around a northbound left movement from a major intersection. It's a very high volume left turn. It's a dual left turn. It's a common route for schools. It provides access across a valley that before didn't have access before, so a bridge was recently put in. Now cars are taking the cut through more often and in large volumes. So often there's a lot of complaints about this movement because maybe they're not getting enough time or it's not being serviced in the way they need it to. And it tends to become a common data set to go back and review, is it doing what we want it to do? So our customer went in and they created a quick dashboard around it. It was looking at that northbound left. The user here was really looking at how much green time are they getting? Is this left turn operating in an interval that I expect? So is it accounting for the volumes? Is it for some reason in a fixed time, or am I giving enough time to this movement? How well is that really operating in terms of the timing allocation that's getting it? and then really looking at the approach volume fluctuation. So the assumption was this is how many cars it's planned for, how many are actually arriving, and what volumes are they arriving in to compare to those to the amount of time that's allocated. From there, you can really break down the arrivals on red to understand how many people are properly getting there when they should, and how well is it coordinated downstream to getting the green time. So these were the common questions that this user was asking of this particular movement, of this particular intersection, to a point where they went in and created a dashboard around it so that they could simply update once a week or once every other week and present back. It's still operating the way we expect it to. The volumes are generally the same. We haven't seen a fluctuation with school in, school out during COVID. And so this becomes a way that you can constantly monitor the same problem over and over again. So very good example of how a simple thing could be turned into a dashboard using a workspace tool. There's a lot of examples of this. It doesn't have to be a particular movement like this. It could be an intersection operation for overall split failures. But if you do have examples, or you do have questions that maybe you want to set up in your own account, please reach out and ask for help. We can certainly build some examples for you. Eventually, I'll probably get around to every one of our users and create a dashboard just from what I see in the data, but not necessarily in context to a problem you may be trying to solve. So I'd be very curious to see what other people are trying to do with the dashboards and how the charts are being created. And it's also a good way for you to share with us what you're trying to do. So in the past, we would get an email, can you help me solve this problem? I'm like, well, what data are you trying to look at? This actually gives you a way to create a dashboard and then share it with the Miovision team to ask questions about, like, this is what I'm making an assumption from this data, or this is the conclusion I'm drawing. Am I right? Am I wrong? That way we can even go look at your workspaces and help you through that. So I would encourage you to take advantage of that and see if you can use it as a tool to learn from as well. So that's our workspaces tool. So I'm gonna hand it over to Olivia. So I did a little bit of a fast run at what charts are available, where the data is coming from, how you can compile a dashboard of data. But we are talking a lot about that there is a lot of data. So what Olivia is gonna take you through now is a new tool that we've created called Intersection Health that actually helps you actually look at the data and actually surface up common problems. So I'll hand it over to you, Olivia, and maybe you can take them through the rest here.
Perfect, thanks, Brent. So getting into an intersection health overview, you may or may have not gone into the tool yet, but pretty handy tool. Just kind of an overall summary of what we're trying to get at here. Actionable insights automatically surface to help you fix problems rather than look for them. So it's kind of feedback we were hearing a lot from customers was, hey, this is great data, there's a lot of it. I don't have the time, I don't have the resources to necessarily search through all of it every day or every week and pull out problems and then solve them. So is there a way you guys can kind of find my problems automatically for me? So that's when we started to work on what is now called Intersection Health. So in creating this tool, we kind of evaluated over 200 intersections and came across some common problems. So about 50% of the intersections we looked at had some sort of suboptimal green split. 38% of intersections had a phase termination issue, and 41% of the corridors that we looked at had poor coordination. So through these trends, we decided that these would be the three main issues that our tool would try to surface. So what do I mean by each of these problems? So just a high-level overview, suboptimal green splits, we're looking at an imbalance between movements. So an imbalance between competing movements. An example would be, in this case, the northbound left and the southbound through are directly competing with each other for time. Say the southbound left movement was really struggling and had a lot of split failures, and the southbound through movement was experiencing a lot of excess capacity. is there an opportunity to shift some of the green time between those two movements to have a more balanced performance? So if we see that imbalance, that's what we consider a suboptimal green split, and that is now flagged. The next issue that we're flagging is phase termination. So this is more so looking at a movement in isolation, generally a minor movement or a left turn. So in this example, we're looking at the left turn there, the northbound left, and say it's getting maybe 20 seconds of green time and it's only using half of that. So we have about 50% spare capacity, which is inefficient. So we're wasting some of that green time that could be maybe reallocated to the eastbound, westbound, or just dropped out of the cycle length completely. So we're just wasting green time there. The phase is not terminating properly. So that's where we would flag a phase termination issue. And lastly, we have poor coordination. So we would flag this if you had a corridor that was configured within TrafficLink and there were not kind of platoons moving nicely through the entire corridor, hitting all those greens. We would consider it poor coordination, maybe if you're kind of stop and start at each intersection. That would be an example of poor coordination. So platoons of vehicles unable to smoothly traverse down the corridor. So now I'm just going to go through 3 examples, so one of each type. A lot to consider here, so I'll try to kind of get into some detail to show a couple of examples where the customer has made a change and a couple of examples where there might be some possible solutions that haven't yet been employed. So here we have example 1, suboptimal green split. Again, for a suboptimal green split, we're looking at an imbalance in performance between competing movements. So in this example, we're looking at this intersection and we're specifically looking at the southbound left movement. So this screenshot is actually currently what is happening within TrafficLink. I'm going to be looking at an example from October before the customer had made any changes. So at that point in October, this southbound left movement was flagged for a suboptimal green split during all periods, so AM and PM, weekday and weekend. So specifically for this example, I'm going to be looking at AM weekday from October 2020. So if I get into the example, typically, I'll just go back for a second. Typically what I would do from this point is I would then look at the split trend information. So you can kind of see the split trend information summarized on the left here. It is helpful, but I like looking at it visually within our split trend charts. So I would go into the analysis view, which is this guy, and generate a split trend chart like this so you can see all of the movements at once. So again, we're looking at the southbound left movement. We're looking at the AM during the weekday. So this is a month of data summarized. So this is October. And we're looking at these bottom 2 charts here. So the southbound left and the northbound through, the competing movements. So you can see the southbound left in the morning, there's that big spike of split failures where not every vehicle is able to make it through the light during that green time. So lots of split failures there. And then in opposition, the northbound through movement has, it looks like a lot of spare capacity during that same time. So obviously it looks like maybe we can shift some time between the two or just give a bit more time to that southbound left movement. So going forward, I would then kind of dive into each movement individually. So here is kind of a zoomed in version of that same chart just for the southbound left movement. And this is for the entire month of October. So you can see in that blue rectangle that I've highlighted that time where we have a spike in split failures. So it's about 6 a.m. to 9 a.m. give or take. And then, so that's our split trend chart. I would look at how much green time that movement is actually getting. So in this case, this is our phase interval chart. Just reading that phase information directly from the controller, our greens, yellows, and reds. Here I've just turned off the red so you can just see the green and yellow. And you can see at that exact same kind of time period from 6-ish to 9 a.m., we have a max screen of 7 seconds. So clearly, based on the split trend information, that's not enough time for all of the vehicles that want to get through. So the customer decided they would make a small change and monitor it and see what happened. So the next month, we came back and checked the same chart just for November this time, and you can see there's already a dramatic change in that time of day. From about 6 to 9, we have a significant reduction in split failure for that movement. So what did it look like? What did we do? We check back in on the phase interval graph, same time period. They simply changed the green max from 7 seconds to 11 seconds. So a 4-second change, not anything dramatic, not too crazy, just added 4 seconds. And you can see the kind of major change that that provided. And if you're thinking, okay, well, did that completely mess up the opposing movement? Good question. So if we check back in on the opposing movement, on the left there, we have October 2020. We have, you can see there's spare capacity there in the northbound through movement. And then on the right, we have the same chart just a month later, and there's been very little change to that chart at all. So things are operating the same for that northbound through movement and much better for the southbound left movement. So that was our example 1. Moving into example number 2, phase termination. So again, just a quick review, phase termination is specifically looking at one movement that is wasting green time. So a lot of the times it'll end up being an actuated left turn, which it is in our example here. So this is an example that's currently within the platform for February 2021. Just as a reminder, if you're looking at data from March, or if you're looking at data right now, it's actually surfacing issues from the month prior. So right now, if you go into the platform, we're looking at data and intersection health alerts from February. So on April 1st, you'll then get data for March. So this is a February 2021 issue. We're looking at a phase termination issue during the AM weekday. You can see that the movement that's highlighted on the map is the eastbound left turn. And it is highlighted because, as you can see in this box, we have spare capacity of 78%. So 78% of the green time that's being given to that movement isn't necessarily being used. So it definitely looks like there's some time being wasted. So what I would do is, again, look into how that movement is operating. So we can go and create a workspace to look at this, generate a few charts like our split trend chart and our phase interval chart. Split trend, again, that's the information that we're looking at to generate this intersection health alert. And again, we're looking at AM. So you can clearly see there's lots of spare capacity, lots of blue here in the AM, kind of 6 a.m. to noon is when we're looking. So obviously some wasted green time there. And then to get a better understanding, we can look at phase interval chart to see how much green time is being given to that movement. So in this case, it looks like throughout the whole day, we have a max green of 20 seconds and a min green of 7 seconds. And maybe what we thought would be happening is that maybe it's not hitting that max green very frequently, but it is in fact hitting the max green relatively frequently. So it's interesting because it's being extended maybe too long. So something to look into would be maybe extension time. So we can look at extension time in one way within our platform, and that would be to look at the telemetry data. So this is what our telemetry page looks like for this intersection. And I'm specifically looking at eastbound left. Again, that's where intersection health flagged an issue. So eastbound left is highlighted in this kind of blue box. We're looking at the timing here. So I just specifically wanted to show this example to show you that maybe extension time is the issue here. So you can see this eastbound left movement was actuated. So there was a vehicle in the detection zone. And because there was a vehicle there, it was called. So that's a good thing. phase should be called, right, if it's being actuated, so that's good. So it was given the green, same with the opposing westbound left, they were both given the green. And then after about 6 seconds of that detection zone being actuated, so maybe 1 or 2 vehicles moving through, there was no more call. So maybe the 2 or 3 vehicles moved through the intersection and then there were no more vehicles in the queue. But after that 6 seconds, it continued to receive that green time for another 5 seconds. And 5 seconds is a pretty long extension time. So definitely something to look into. It could be an extension time issue. So my last example here is for poor progression quality. So again, just a quick review of poor progression quality. If you have a corridor that's been configured within TrafficLink, we will look to see if platoons are moving well through that corridor, if it's being coordinated as expected, or if it's kind of a stop and start situation. So in this example, you can see in the top here, we have poor progression quality, and it says for the AM weekday. This data or this alert is not looking at things like split trends. So you don't have any of that same information, that same summary information here. To generate this alert, we're looking at things like distance between intersections, and we're looking at signal timing, and we're looking at speed, that sort of thing. So we don't have any high-level summary metrics here. We just have that the 2 directions that are the issue. So in this instance, eastbound and westbound are kind of the predominant direction and where coordination is occurring. So coordination is occurring in the eastbound, westbound directions here. So a couple things to walk through. So to begin with, poor progression quality, what we're doing is we're looking at a corridor. To begin with, you have to have a corridor that's configured within TrafficLink. So if you have that, great, good. Step 1 complete. Step 2 is that the corridor actually needs to be configured. Or sorry, not configured, it needs to be coordinated. So if you have a configured corridor, but it's not coordinated, then we're, again, not going to be evaluating it for poor coordination. Makes sense. So if both of those things are checked off, we have a corridor that's been configured and it is coordinated, then we can start evaluating it. So the way that we evaluate it is we break the corridor up into sections of 3 intersections. In this case, for this example, this corridor only has 3 intersections, so a good example. So we break it up into 3 and we look at the middle intersection. So that's our focal point. And then from there, we're looking at kind of the bandwidth between that intersection and the other 2 intersections in both directions. So we're calculating using things like signal timing, cycle length, speed, and distance between the intersections, kind of how wide those bands are of time that kind of a platoon could move from one intersection to the next. We do that calculation and we have what we call an efficiency score. And so our efficiency score is broken down into kind of poor, fair, good, and great. And if that score is poor, then we flag it as a poor progression quality. So something to do that's kind of an obvious way of looking at this is you could generate a time-space diagram. So just a super easy visual way to understand how your corridor is behaving. So we get into that through the analysis view, we look into corridor, and then we pick our corridor and a time of day, and that will generate something that looks like this. So this is our time-space diagram for the corridor that you see here, and this is from 11 a.m. to 11:15. So a couple things to notice here. It looks okay, right? First glance, looks okay. We're looking at 3 different intersections. We're looking at the time, the signal timing information for each, and then we're looking at these bands that are showing how vehicles could move from one intersection to the next, all in a nice platoon. So in this case, something to first notice is that we do in fact have the same cycle length from intersection to intersection. So that's one of our criteria before we even look at this intersection to analyze is it coordinated? Does it have the same cycle length between the intersections? So they all have the same cycle length, you can see here. Again, it doesn't look too bad from first glance. You can see the purple bands are actually representing westbound coordination. What we would like to see for coordination is consistent bandwidth. So you're consistently getting the same length of progression, so the same time, and happening the same every time. So from that point of view, it looks pretty good from cycle to cycle, same amount of coordination. What you might forget or might not notice is that while westbound looks okay, in theory, we should have eastbound coordination as well. So we should have kind of an opposing band that looks like that. That's moving in the opposite direction. So what it looks like right now is we have pretty good westbound coordination, but absolutely no eastbound coordination. So then you can understand why this was considered to be poor progression. Because if we're calculating that efficiency score, it's pretty good in the westbound direction, but it's actually 0 in the eastbound direction. There's no coordination happening at all. So on average, it comes up as poor progression. So that is the end of my portion. I think I'll turn it back over to Brent to talk about a few things before we wrap up.
Yeah, that was great. Thank you so much, Olivia. I was thinking, because we have about 10 more minutes, I was thinking maybe I could do a quick tour in TrafficLink. Let me share my screen. I think I'm sharing my screen. Is it still sharing, Olivia?
I can see it, but
Perfect.
I don't know.
Yeah, I think that's good. As long as you can see it, that's good.
Yeah.
So you hit on really a lot of really good points. And what I was thinking I could try and do here is, I find the slides really helpful in going through the walkthrough, but when everyone goes out and tries this on their own, maybe I can give a quick tour of where some of the aspects are directly in TrafficLink here. Maybe hit on some topics, maybe just solidify what Olivia was saying, but since we have a few minutes, maybe helpful. And then I'll go back to the slide deck. Oh, I'm zooming the wrong way. All right, I'll give a little 5-minute tour here, and then we'll open up for questions to everybody. While I'm going through this, if you're thinking about your questions, I think there is a chat box that you can use. Maybe that's the best way to do it, but we'll come back to that in a minute. So here's TrafficLink. I've done a couple webinars in the past where I've used this account here, and so you may have seen a little bit of this before, but I'll give a little bit of a tour of where you can find some of the features that Olivia was highlighting there. The first one that I'll get into is just where is intersection health. So when we first log into TrafficLink, you see all of your points on the map, you see the intersections. If you go along the left and you go to that Insights tab and you click on that, the first thing that comes up is actually intersection health. So this is the first thing that you look at from context. The idea here is almost don't start with all of the data points. It's almost start with where the problems are. So where are the problems, and then start drilling down. Unless you know of a particular situation at an intersection, or you're handling a citizen complaint where you're investigating into the data, typically you need a starting point, and intersection health is a great starting point to start digging into problems. So when you first log in, it highlights them immediately on the map. And as Olivia was saying, the first thing you'll notice is there's no time frame indicated here. So when you first look at it, what data set are we looking at? What are the parameters of this? And it is looking at the previous month, as Olivia was talking about. So we're looking for persistent and consistent problems in the network, not day-to-day fluctuations, more so a problem that's commonly there throughout the duration of an entire month. That's why we do the, if you're in March, we're looking at February. We almost want to see all 30 days of the previous month, or I guess February 28. And so was really looking at those very persistent problems in the network. That way we're looking at a larger data set, We're not accounting for things like an event day, if those are still a thing during these COVID times. If there was a parade and whatnot that changed the timing for a day, it won't really surface in the data. It's really looking for the normal operational aspects that are persistent throughout the entire month. So here we have two problems. I'm not going to get really into the problems because Olivia covered them really well, but just to show you, when you go to the intersection, they highlight, and I can go either way. I click on one, it brings us right to that chart that shows us the problems. I can go back, click on the other one. It gives us that same view. It breaks it down. So we do AM weekday, PM weekday, AM weekend, and PM weekend. So it kind of generalizes where is the problem in the day. And that's why you have to go to the charts to really figure out what specific time is the problem. Is it a part of my time of day plan, or is there another thing there that I need to look for? And that's why you go to the charts to figure that out. In the future, we're going to start opening up what time frames and what time of days a little bit further so that you can get a little bit more creative. But we wanted to start with this first iteration in the sense that let's just start surfacing the most persistent problems in the network and then start working our way outwards from there. From there, we can then go to that workspace tool here where we can pick a particular dashboard that may already exist around a particular problem, or we can simply create a new one. And that's where you can just simply add your charts. So if you're wondering where are my charts, it's in the workspace tab. Go to create new on the right, or open up one of maybe the demos that we created. If you see Mioadmin as an author on one of the ATSPM workspaces, that's because we set you up with a demo or we were looking at a particular problem with you. But you can simply create a new one on the right. And when you add a chart, this is where all your charts are now if you're looking for them. So that's where those main aspects are in TrafficLink and where the problems could be found. One of the couple other charts that if you're not familiar where the analysis tab is, this is where we look at more holistic data sets. So ATSPM charts are about individual movements, individual data points, whereas the analysis tab, the one to the bottom, so it goes insights, then analysis, this allows us to look at those corridor metrics or those intersection metrics holistically. So if we wanted to pick one, what was one that was just highlighting there? I don't know, let's see if the first one works. We'll just add a chart for all of the split failures. So this actually populates every one of the movements that has data. So that way I don't have to go in and actually create every one of my charts. I could just go to the analysis tab and generate all of them. Looks like there's something that we can do here about this eastbound through. But that's how you can look holistically at all of the movements. But when you're thinking about a corridor, up at the top here, we also have the corridor metrics, where you can go to the corridor side. We can look at one of our larger corridors. So if we have, let's look at Thompson Street here, because I think that's a pretty long one. This is where you find that time space diagram that Olivia was showing. When you click on it, you choose a start time. Let's pick noon because that's a time. And then it generates your charts, and you can change up that configuration a little bit to get you a little bit more visibility. So there we go. We can see more of these charts, and you can play around with this, what the speed of the road is, to see if you can maybe pinpoint exactly how fast cars are driving. Maybe you can derive that from the congestion scan that actually gives you relative space mean speed. You can derive that exactly how is the timing plans being impacted based on what we have from the signal and where each one of them are connected along the way. And this is where those charts actually, the intersection health is looking, and this is the tools that you can use to really put the pieces together, as Olivia highlighted. Corridors obviously is a big part of that. So if I go right back to the map, often I would love to ask this question to every customer in the sense of what corridors do you care about and what are configured in TrafficLink. That's often a good starting point to get to the at least 3 configured for the chart. And when we do that, we can work our way through and help you configure them. Miovision, we help configure all the time, but not always do we know what is a corridor in your frame of mind, in the sense of I can tell that there's a series of intersections around a road, but I don't necessarily know how have you coordinated them. What is the cutoff point of a coordinated range here? And so what we have is a concept of corridor in TrafficLink. When you click on the top magnifying glass up here, it actually lists your corridors first. and then it goes into the individual intersections below. So if we were to click on that same Thompson Road that we saw the time space diagram, we can see the 5 intersections that are a part of that corridor. But that's because just this section may be coordinated, but maybe not the entire road is coordinated. But we can easily add to that corridor. We can keep building it. We can do the east-westbound version, and we can get a good common idea of what do we call a corridor and what do we want to assess within that corridor. Many of the cities I work with have to work with different jurisdictions, so state DOTs alongside of a city DOT, and then the problem actually lies in cycle lengths between how a DOT does it versus how a city does it. And those types of challenges can be surfaced in the data if we configure the corridors as such. So I encourage you to go look at your corridor configurations, make sure all the right intersections are included. It's fairly easy to add them. You can add them yourself. You don't have to get Miovision to do it. When you're on the main map, if you go to the bottom left here, there's a configuration icon. If you click on that, it says add an intersection or add a corridor. So you can create your own corridors very easily and you just line them up. The major factors of lining them up in a coordinated sense is the distance. And so making sure that the distance calculation between every intersection is done correctly. I often use just basic tools like Google Maps. When you have Google Maps, you can simply measure how far is it, and then you input in between each intersection the distance, and then your corridor is created. So it's a fairly simple process, but a lot of the poor progression data comes from that corridor configuration. So I encourage you to go look at that. Make sure the corridors make sense to you in the sense of what you want evaluated. Obviously, if it's not configured, you won't get a poor progression alert around it. Miovision is happy to help configure them. If you send us a list, I want all these intersections and corridors, we'd be happy to help you set it up because we're just as interested in the data as you. But you can once you have that, you can really get into those tools a lot more. You can look at the alerts that are generated from it. You can look at the current travel time speed, that's current travel time and speed. So if I actually click on the next button down, which is the dashboard, you can actually see what is the relative speed in comparison to the travel time. This is a Canadian customer, so it's in metric. But if you're in the US, it'll show in the correct miles per hour. So this gives you both travel time and speed as currently across the corridor. And as well, when we dive into those ATSPMs, it gives you the full congestion scan based on the same data. So if you're not familiar with all of those tools, they are available to you. The corridors are a big part of it. Feel free to get them set up. If not, you can go ahead and reach out to us. So I'll quickly just wrap up here, and then I'll open it up to see if there's any questions. We do have a video library available at training.miovision.com. We also have help.miovision.com. We have a lot of resources available to everybody. So you can go in, you can rewatch this webinar, you can watch any of the existing training videos that we have. You can obviously book time with us, but lots of material is online if you want to learn on your own. Feel free to go check those out. The videos are very helpful. Catherine, who builds them, is a really good trainer. She does a great job of structuring training material. So check out her videos, send her some feedback. She loves to hear what else she could add to them. So feel free to do that. The Help Center itself is just a giant knowledge base. We have lots of articles. Every time we learn something, we try to add it to the knowledge base to make sure that everything is written down as we go. This knowledge base, at some point, we hope our users can even take a part of about examples and add in their own examples and whatnot. So check out the Help Center, very robust tool. See if you can find what you're looking for. If not, at the bottom, there's our contact information. You can reach out to either of us and get what you need. Obviously, you can follow into your sellers if that's the path you like to follow as well, but check it out. But yeah, I'll wrap up here. You can join us at our next session. I'll double check this date. I probably should have warned Shannon I had a date in here, but we do have a next session in early April around cycling back to our detection and counts. So if you're familiar with this training program, we do them in intervals. So it goes detection and counts, signal management, and then performance measures. So today we're talking about performance measures, but now we're going to cycle back to detection and counts in our next session. So look out for the invites to that for the April session, and we'll dive deep into the next one around detection and counts. In the meantime, Olivia and I will hang on the webinar here, see if any questions come through the chat window or wherever else they may come. I think I can only see the chat on my side, but if you do have any questions, feel free to send them our way. We'd be happy to answer them. We'll hang on for a few minutes to see if we hear anything. If not, have a good day. Thank you so much for attending, and we'll send out this video afterwards. Thank you so much, everyone. I test it here. The chat window works. Awesome. I'm not seeing any questions come in, so we'll wrap it up here. And thank you everyone for attending, and feel free to reach out to us if you have any other questions. Thank you so much.